Aqueous and gas. Yep, both. So aqueous and gas both go in the KEQ expression. All right, so that's concentration of H2, concentration of S2 over the concentration of H2S. Are we happy with what I've written? We need the coefficients, right? But we don't write them as coefficients, we write them as exponents. So that's going to be squared and that's going to be squared. Now, unless you are given a 1 liter flask, you should show your calculations for concentrations. And just for people on the video, this is 2.3B, number 5. Okay, so show the calculations for the concentrations. Unless you just have 1 liter. So in this case, we do need to show our calculations. So H2S, we are told we have 2 moles, and that is in a volume of 2.00 liters. We are told, and that will give us 1.00 molar. We also know that we have H2, and that is 1 mole in 2.00 liters. So that's going to be 0.500 molar. And finally, we are asked how many moles of S2? Can we find moles of S2 directly, or do we need to find something else first? Well, yeah, it's in a 2 liter flask, but we're probably going to want to find concentration of S2 first. So the concentration of S2 is what we don't know. And then we're eventually going to use that to find the moles of S2, okay? And I'm going to get rid of this because it's just taking up space at this point. There we go. So let's start plugging things in. Do we know our KEQ? Yes, we do. It's right there. So let's plug that in. Oh, actually, I should do my solving first. So let's solve for S2. I'm going to show all the algebra in gory detail for this one, okay? So I'm going to multiply both sides by H2S squared, because that's going to help me to get S2 all by itself. And I'm also going to divide, what I do to one side, I must do to the other side, H2S squared. And I also need to, if I'm isolating S2, I need to divide this side by H2 squared, which means I need to divide the other side by H2 squared. And that'll cancel out those. I'm just going to rewrite this because it's a nasty mess right now. I'm going to take my S2 and write it over here. So concentration of S2 equals, and then I'm going to write all of this over on the right-hand side. So H2S squared times KEQ over concentration of H2 squared. So this one, H2S, we can start plugging things in. That's going to be 1.00 molar. And remember, now I'm using what kind of brackets? Round brackets. And my KEQ was, let's go find that value, 1.62 times 10 to the minus 2. 1.62 times 10 to the minus 2. Oh, and I can't forget to square that, although it doesn't really matter because it's a 1. It's just convenient. And now H2 is 0.5. 0.500 squared. And so our concentration of S2 is 1.62 2e2 negative divided by 0.5 squared equals 0.0648. Now, when I get to this point, I should always be asking myself two things. I should be asking myself, is this, well, actually, I should be asking three things. Is this what I wanted? No, I actually want moles of S2. And what have I found? I found concentration, that's moles per liter. However, what do I know that will help me? Yeah, if I get rid of all this, so you can actually read the question again, you can be like, oh, look, it is in a 2-liter flask. So we can use that 2 liters. I just do want you to be careful. This is something that I see a lot. People get to this point and they all of a sudden write times 2 liters. Is that okay? It's not okay because these two things are equal to each other, yes? If I calculate out 1 times 1.62 times 10 to the minus 2 divided by 0.5 squared, I get 0.0648. I do not get 0.0648 times 2. Does that make sense? So I cannot do that in the same line. I have to say, okay, I want to find my moles of S2. So that's going to be 2.00 liters times 0.0648 moles per liter. Liters cancel out, and we get 0.1296. Once we are at our final thing, we check back in the question, did we want moles of S2? Yes, we did. Yay. Am I done? You should be asking two things. Sig Figs. How many Sig Figs? 3. There's 3 here. There's 3 here. There's 3 here. So that should be 3. So that's going to become then 0.130. And my units, what are my units here? Moles, and I'm going to write moles of S2 just, because that's more precise. Okay. So that's the kind of question that you'll get if you are already at equilibrium. We're going to do, did you want number 3 or number 4? You wanted number 3. So why don't we start with number 3 and then we'll see if we actually want to do number 4. Okay, so this is 2.3c. So I think we're on page 90. Okay. So, do we need a race table here? So we're going to ask ourselves, do we need race? Do we need Q? If you see the language, blah-de-blah-de-blah, were placed in a 1-liter flask, how likely do you think it is that we dumped some stuff into a flask and the amount that we dumped in was an equilibrium mixture to start with? Not likely. So anytime you see were placed in a 1-liter flask, this means these are your initial conditions. And if you have initial conditions, then you have an I, which means you're going to need to use a race table, okay? You need race. Another way you can tell that you need race is if you see allowed to react. That also means that you need race. So both of those are telling you need a race table. Do we need a Q? How do we know if we need a Q? You need a Q if you are given an initial amount for all the substances. Are we given an initial amount for all the substances? We're given an amount for SO3. We have SO3 initial. Yes. We are given an amount for NO. Do we have any NO2 or SO2? No. So these guys are at 0. And I guess I should say if you're given a non-zero initial amount of all substances, because we are given the concentrations of the NO2 and the SO2, it's just that they are 0. The reason we don't need it, Q is only there to tell us which way the equilibrium shifts if we have both things present. If we only have the SO2 and the NO present, which way does it have to shift? It has to shift to the right, so we don't need to use a Q here, okay? So if that's the case, then we are going to start with a race table, which sadly I'm gonna have to do over here, but that's all right. So we have R, I. Why am I putting square brackets around the I, the C, and the E? Because those are my initial concentration, my change in concentration, and my equilibrium concentration. My reaction, SO3 plus NO, SO3 plus NO. Let's check and make sure that those are things we want to include. Yes, it's a gas. Yes, it's a gas. NO2 and SO2 are also gases. NO2 plus SO2, those are all gas, 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 gas. Is this a situation where I need to show my calculation for my concentrations? If you have 1 liter, you can just be like, oh, it's too easy, I don't need to worry about showing the calculation. So I can just say that my initial concentration of SO3, 3 moles in 1 liter is, or sorry, 0.300. Yeah? My initial concentration of NO I have 3 moles in the 1 liter flask, my NO, and so that's just going to be 0.300. How much NO2 and SO2 were placed in the flask? 0. If I don't tell you any was put in there, then there wasn't any put in there, so it's 0. So if they are not mentioned, their concentrations initially are 0. So in our race table, this was 0.300, this was 0.300, this is going to be 0, and that's going to be 0 molar. It's optional if you put this molar in. I'm just going to put it in here so we know what we're talking about. So this did not say that any was placed in the container. Therefore, 0 was placed in the flask. Do we know which way this is going to shift? Yes, it has to shift to the right, which means I can put my pluses and my minuses in my table here. And so my products have to be increasing and my reactants have to be decreasing. Are there any coefficients to worry about here? No, no coefficients. Now, we have to decide, is this a question where we're going to use X, or is it a question where we have an equilibrium concentration? Let's go back and look at our question. What would be the equilibrium concentration of each gas? Well, gosh, if we're being asked for that, we certainly don't know the equilibrium concentrations. If we're not given an equilibrium concentration, what do we use? X. And these are all just going to be 1x because all the coefficients are just 1, 1, 1, 1. So 0.300 minus x, 0.300 minus x, x, and x. How many marks is writing this table worth? 1.5 to 2 marks. And if your question is out of probably a maximum of 5, that can be probably more like 4. That can be as much as half of the marks in the question. So don't not write this. Do not write it. This is lovely. What do I do once I have a completed rice table? Kek equals NO2 times SO2 over SO3 times NO. And now we go back and say, what was our Kek? What was our KEQ? It was given to us, so it is 0.500. So we're going to write that in, 0.500. Both of my products are X at equilibrium, so that's going to be X squared. My reactants are 0.300 minus X, so I'm going to just square that. And chemistry 12 is lovely. You are never going to have to do a quadratic equation unless you want to. So, well, if you want to, you can. If you wanted to expand this thing out and solve for X, anybody? Not here. Okay, I'm good with that. So you'll notice that you'll end up with a lot of things where it's a squared term over a squared term, which will allow you to just take a square root of both sides. There are other situations later on where we don't have squared over squared, but there's a few little assumptions we can make where you're making a little bit of an approximation, but because within Sig Figs it works out, you'll end up with the same answer. Okay, so we do this. 0.5 square root gives us 0.7071. I'm keeping one extra digit so I don't get a rounding error. Square root of x squared is x. Square root of 0.30 mole minus x is 0.300 minus x. Do we want big algebra or little algebra? Little algebra, big algebra? Okay, I'm going to do big algebra. Okay, I'm going to multiply both sides by 0.300 minus, what? Is that right? That's what I'm doing, yes. 0.300 minus x. Sorry, I had a little brain glitch. There we go. Now I'm going to take 0.300 and I'm going to multiply there, and I'm going to take my negative x and I'm going to multiply there so that I expand that out. So 0.3 times 0.7071 gives us 0.2121. And now I have my negative x times 0.7071, so that's going to be minus 0.7071x equals x. To both sides, I am going to add 0.7071x. Now remember, if we just have an x here, this means how many x's? 1x. And just in case you're a little confused by the math, what do I get if I take 1 plus 0.7071? I get 1.7071. So if I have an x behind that, that's just going to be the same thing there, okay? So I'm going to end up over here with 1.7071x, and over here these two cancel out, and we're left with 0.2121. Divide both sides by 1.7071 to get x by itself. And I like putting my x on the left-hand side, but you could leave it on the right-hand side. That would also be fine. Divided by 1.7071 equals 0.1243. And whenever you get to an x, what do you need to ask yourself? What's the question asking for? And this one, I don't like this one because it asks for the equilibrium concentration of each gas. That's a pain in the ass, yes? You're not going to get that on a quiz because that means you're going to do like calculation. But can we just do one of them as an example? Let's say we wanted to find the concentration of SO3, which is also the same as the concentration of NO. That's going to be 0.300 minus X. So the concentration of SO3 is equal to the concentration of NO, and these are my equilibrium concentrations. And you just go back to your rice table and you say, what is it? 0.300 minus X. 0.300 minus X. And so that's going to be 0.300 minus 0.1243 equals 0.17557. And what's the last two things we should ask ourselves? Units and sig figs. Now we have just done a subtraction. What do we do? What's the rule when you have a subtraction? How many decimal places? Yeah, because our uncertain digit is here, we have 3 decimal places. We're going to round this to 3 decimal places. So that's going to become then 0.176. And we have to ask units. Do we need units? If it was a KEQ, we would not need units. Is this KEQ? No, what is it? Concentration. So does it need units? Yes, it does. What are the units of concentration? Square bracket concentration? Moles over liters, so you can write that like that, or molar. And there we go. I'm not going to write a substance after that because I've actually got both of them here. Okay? How about I leave number 4, and if we feel like we want to do it later, we can come back to it because I'd like to make sure we do one from 2.3D. Sound good? Okay, so let's go to 2.3D. And we're going to do number 3. So I think this is on page 93. So the first 2 things you need to ask yourself when starting a question. What's the first thing you ask? We need a rice table And do we need a Q? How do we know if we need a rice table? Is there any language in here that tells us we need a rice table? Are placed in and allowed to achieve equilibrium. Okay, those both let us know that we need rice. How do we know if we need a Q? Pardon me? Yes, but the key thing is you need to be given initial non-zero concentrations of all your substances. Are we given non-zero initial amounts of all substances? Yeah. And the answer is yes, we have 1.50 moles of each chemical species. So that means everybody has an initial concentration, which means that we don't know which way we're going to shift. Always shift towards the zero. Oh, but there's no zero here. Yeah, so we need to figure out which way it's going to shift. I will let you know, you can just solve this by brute force and hope you put the plus sign in the right place. I will not give you full credit for doing that. I want you to recognize that you should use a Q here, and I'm going to give you credit for actually writing the Q. If you need a Q, you must use a Q to get full credit. Okay? So we need a Q. Shall we do Q first? How do you write Q? What's the expression for Q? It's exactly like what? Exactly like KEQ, but what do we use instead of equilibrium concentrations? Initial concentrations. So again, products over reactants, products, CO, H2O, over reactants, which is H2 and CO2. Oh, everybody's a gas, I'm checking, yes they are. If they were aqueous, would that be okay? Yes. CO2. And these are all, because I need to remind myself, I'm going to put little I's beside them all because they're all initial quantities. I was not kind to you here. I did not give you a 1 liter flask. If it's not a 1 liter flask, show the calculation for your concentration. So you're going to need to show, and fortunately, oh, guess what? They're all the same initially. So you can say the concentration of H2 initial equals the concentration of CO2 initial equals the concentration of CO initial equals the concentration of H2O initial equals, that was a lot of work, but this part's going to be easy, 1.50 moles over 3.00 liters equals 0.500 molar. Oh, that also means our Q value is going to be really easy to solve for because we have 0.500 squared over 0.500 squared equals how much? Even I can do this one in my head. 1. Yes? What do we do with a Q value? We compare it with the KEQ. What do we do with Q? With Q, compare to KEQ. And the best way to do that is to write out, okay, I got my Q. What's its value? It is 1. And I got my KEQ. What's its value? It is, up in the given to us up in the question, 3.4, whoops, not 4959. Is Q bigger than KEQ or less than KEQ? Less than KEQ. Now, if you are at the point where you can write, okay, Q is less than KEQ, therefore we must shift to the right, you can do so. However, that's a pretty big leap. Yes, we're leaping like 3 steps by doing that. So even though this is all you are required to write, this part is what you're required to write, I would suggest to you that it is a really good idea to write down your thinking process for yourself. Also, if you make a mistake in your thinking process, I'll be able to see where you made your mistake and give you some pointers, okay? So, the thinking process, you can write, if you want, Q, which is equal to the what over the what? Products over the reactants. And it is it too small or is it too big? It's less than KEQ, therefore it is too small. So normally I just look at this and I say, does that mean I need more products or does that mean my products are too big? Yeah, if it's too small, therefore we need more products. And if we need more products, because that's on the top, right? If I have a bigger number there, it's going to get bigger. If it had been too big, I would have said, I have too much products. I need to shift away from the products. So we're going to shift towards the products. And if my brain is not telling me which direction that is, left or right, I'm going to write reactants, products, and I'm going to be like, oh, that's going to be to the right. Okay? Like I said, if all of that takes place in your head and you're happy with that, you can just write that, but that'll get you there. And wouldn't it be nice if we were done? Because, Lordy, this is a long question, but here we go. So we've decided we need to shift to the right. We have all our initial concentrations. We decided, what did we need for this question? We needed a rice table. Have we done a rice table yet? No, let's do a rice table. Okay, so over here we go. R, I in square brackets, C in square brackets, E in square brackets. Whew. Okay, I'm going to make that smaller so I can see everything. We got an H2 gas plus CO2 gas in equilibrium with CO gas plus H2O gas. The only thing I've noticed about all the questions we've done today, we haven't had to use coefficients in the change. So just watch out for that. Like if there were a 2 here, this would need to be like a 2x. Yes? Okay, but I'm just going to get rid of that because there is not a 2 there. Okay. My initial concentrations were all 0.500 molar. So I'm going to fill those all in. 0.500, 0.500, 0.5, 0.5. Okay. And we decided which way was this thing shifting? To the right. So where am I going to put my plus signs? On the right. And that means on my left, I'm going to put my minus signs. Excellent. And now, do we have any equilibrium concentrations? Nope. It just tells us what was placed in the flask. And if they don't tell us what an equilibrium concentration is, then what do we need to put in our table? X, 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 X. As I mentioned before, don't write this in. What happened there? If there had been a 2 here, that would have to be a 2. But it's not, so we're going to get rid of that. And now you just subtract or add your way down. 0.500 minus X, 0.500 minus X, 0.500 plus X, 0.500 plus X. Whew. Do you know how much fun it is typing the answer keys for these? Super fun. Just like fun and a half. What do you do after you've got your rice table? KEQ, KEK. KEK is equal to, and I know we already wrote the Q, and so you might be thinking to yourself, my God, I've already written this thing. Do I need to write it again? The answer is yes. You will get marks for it, so why not do it, right? It's cheap, free marks. Okay. CO times H2O over H2 times CO2. And this time, instead of those being initial, those are going to be equilibrium. You don't need to write in equilibrium. It is assumed because we have the KEQ there. But I'm just writing it in to make sure that we remember. Plug in these guys. Oh, 0.500 minus X. Oh, my product, it's plus X. There we go. So I got to write plus X, and that's going to be squared over 0.500 minus X for my reactants. Squared. KEQ was 3.59, 3.59. That has to be given to you in the question. You can't just pull that out of nowhere unless that's what you're solving for. What do we do next? Solve for X. First step of solving for X is to, yep. Tell your partner, what are we going to do first here? What do we need to do in here? Get rid of what? Of the what? Of the denominator. Oh, I could do that, but then I'll end up with what? A quadratic. I have to square root first, okay? Otherwise, I'm going to end up with a quadratic. If you end up with a quadratic expression, if you're expanding out and you've got an x squared term in there, you'd be like, oh, I need to go back and I need to take a square root, okay? Because you might get to the point where you've like, oh, I moved that and oh, dang, oh. Okay, so don't, yeah. So square root first, la la la, la la la. 3.59, square root, 1.8945, one extra digit equals 0.500 plus X, 0.500 minus X. I'm not going to be quite as showy of all the algebra for this one. I'm just going to do it a little bit less, 1.895 times 0.500 minus X equals 0.500 plus X. You can show as much or as little of the algebra as you wish. If you make a mistake and you haven't shown where that mistake happened, I cannot give you as many part marks. Do you know what I mean? So show, like what I'm showing is kind of, it's what I would do if I were doing it. 1.895 times 0.5, 0.9475. Minus, now we're going to do this term here, 1.895x, 0.500 plus x. I'm going to combine all my x terms. So that's going to be, what am I going to get? 2.895x, yes? Huh? Oh, but I moved it over here. I could make it negative, but I'd rather have positive terms. So I moved it over to the other side. But if you have negative, it just means your other number will be negative and it'll all be fine. Okay, so it doesn't matter which way you do it. So yeah, if you had negative, your other number would just also be negative. Now, what am I going to do for the other ones? I'm going to take 0.9475 and I'm going to minus 0.5. So 0.9475 minus 0.5 is 0.4475. And now I like to have my x on the left, but if you wanted to leave it on the right, that would be fine. 0.4475 divided by 2.895 is 0.1546. Are we good? Are we good? Okay. And wouldn't it be nice if we were done? We solved for x. What do you do when you solve for x? Yeah, we're gonna, before we do anything, we're gonna go back and see what the question was asking for. Whoa, way back here. Whoa, look at all this work. Look how much work we've done. Holy doodle. Yes? Wait till you get to university. You got, sometimes a question will take like 4 pages. What mass of CO will be present at equilibrium? So we want to know the mass of CO at equilibrium. So we want to then, we would need to know our concentration of CO at equilibrium. So the concentration of CO at equilibrium is 0.500 plus x, which is equal to 0.500 plus, what was that number we had? 0.1546. 0.1546 plus 0.5 equals 0.6546. And my units for that are moles per liter. And no, we're not done yet, because what did we want? We didn't want moles per liter, we wanted grams. Okay, so, and remember, I cannot just go, oh, what was a 1 liter flask. Whew. So, was it a 1 liter flask? I think it was. 3 liter flask. Oh, lordy. Okay, so 3 liter flask. So my grams of CO is equal to my 3 liters times 0.6546 moles per liter, which will give me moles, times, and this is CO, so C has a mass of 12. 12 plus 16 gives me 28. So I'm going to have to write that as 28.0 grams for 1 mole, and that's of CO. And we get that times 3 times 28 equals 54.98. And we need to round that to 3 decimal places, so that's going to, or not 3 decimal places, 3 sig figs, so that's going to round to 55.0 grams of CO. And at that point, you go and take a nap because you're all done. Yes? How are we feeling? Tired? Yeah, I am too. Are we feeling like we would like a little more practice on that? Do you want to practice a little on your own? There's Hebden questions. If you're feeling done with this and you want to work on enthalpy and entropy tutorial, that's what we're going to be doing tomorrow. We'll be going over this to make sure everyone's good with it. And if not, you can work on, where did it go? There. Okay? So practice for your quiz. You don't have the quiz till Thursday, so I would actually suggest also working a little bit on that enthalpy-entropy tutorial tonight so you're familiar with it for tomorrow. We are doing the lab on Thursday after the quiz, yes. Okay, so we're doing quiz and then lab. So the quiz is not going to take the whole block, because that would be ridiculous. I don't know. Yeah, but like, I don't know. Yeah. I mean, it's one of my old quizzes, because I've been teaching this course for 25 years. And the curriculum has literally not changed since 1986. So, because chemistry just doesn't change, not at this level. Right? It does change, but sort of like more at like a 4th year graduate level. So we don't have to worry about any changes. However, it's so early that if you were to get caught, I would be in huge trouble. So if you're going to go late for a ride, don't do that. Okay, your glasses are coming this right here. All right. So if you're walking home, or driving, the test is going to take 1 hour and 20 minutes. that be fair? If you got yours and nobody else. No, but nobody else is secret grading. Like my other class is not secret grading. There's not going to be like that last one.